Welcome to our presentation on the recovery of Point Pleasant Park after Hurricane Juan. In 2003, Category 2 Hurricane Juan hit Point Pleasant Park in Halifax, Nova Scotia. Point Pleasant Park is a 75-hectare area dominated by red spruce and red maple trees. Point Pleasant Park is considered a mid-successional stage park, creating opportunities for plants to develop following Hurricane Juan. It is a regrowth phase that supports early and late successional species. Hurricane Juan destroyed between 70 and 80% of the trees within Point Pleasant Park. The storm created large, exposed areas with disturbed soil, increasing sunlight and substantial debris, completely changing the park's environment. Red maple trees are fast-growing. The exposed soil and high sun exposure encourage the growth of the species following the storm. Red maple trees are considered early successional species due to their high recovery rate following the hurricane. The number increasing rapidly as the park recovered from Hurricane Juan. Red spruce trees grow slowly and are shade tolerant. They are classified as a late successional species because of their extended recovery period following the hurricane. Point Pleasant Park is significant for both its ecological value and its importance to the Mi'kmaq community in Nova Scotia. The park contains culturally important species such as red spruce and historically black ash, which have been used in canoe building, basket weaving, and other traditional practices. It forms part of the Mi'kmaq's traditional territory and preserves the history of their use of local plant species. The impact of Hurricane Juan highlights the vulnerability of natural areas and cultural significant resources. The storm disrupted both the fort's ecosystem and its availability of traditional materials. These effects underscore the necessity of protecting and conserving the areas of ecological and cultural importance. The objectives of this study are to determine the successional stage of Point Pleasant Park by analyzing tree density, tree size, and species variety over time following Hurricane Juan, and to evaluate the effects of external influences such as the urban environment and invasive species on forest succession and species richness. We hypothesize that if Point Pleasant Park is a mid-successional forest, then the density of the early successional species, such as the red maple, will increase initially following the hurricane, but level off or decline as late successional species, such as the red spruce, increase in density due to their increased tolerance for resource competition.
In this method section, 6 permanent 20 by 20 meter plots were established in 2004 in areas of Point Pleasant Park that experienced the highest structural damage from Hurricane Juan. These high-impact areas were selected to allow us to monitor ecological recovery and secondary succession over time. In each 400 square meter plot, all living trees that had a diameter at breast height of at least 2.5 centimeters were recorded. The primary equipment used in the field was a diameter measuring tape to measure DBH at 1.37 meters above ground, which is the standard forestry measurement height. Trees were identified to species using a regional tree identification guide. After field collection, raw data was complied to calculate total tree density per 400 square meters, average DBH, species richness, Shannon diversity index, and Pelu's evenness. These metrics quantify both structural characteristics such as size and density and compositional characteristics such as species diversity. To analyze long-term trends in forest recovery, linear regression was used to test for relationships between year and each community metric. Linear regression was appropriate because we were examining directional change over time. Statistical significance was determined at an alpha level of 0.05. Results and discussions, question 1. To answer this question, we're going to be looking at 3 different charts. First one is the total density. Total tree density increased significantly between 2004 and 2025. Linear regression analysis showed a strong positive relationship between year and total density, with an R-squared value of 0.45 and a highly significant p-value of 3.9 times 10 to the negative 13. This indicates that approximately 45% of the variation in tree density is explained by time since the hurricane. These findings support the hypothesis that density would increase during secondary succession. After Hurricane Juan removed much of the canopy, increased light availability at the forest floor promoted the recruitment of pioneer and mid-successional species. As a result, stem density increased over time as young trees established. This pattern can align with the secondary succession theory, which predicts rapid colonization and increasing stem density following major disturbances. Next, we're going to be looking at the DBH. In contrast to density, the average DBH significantly decreased over time. Regression analysis showed a negative relationship between year and DBH, a statistical significant p-value of 0.0002. This decline reflects the influx of younger, smaller trees establishing after the hurricane. In 2004, the forest still contained some of the larger surviving trees. However, as recruitment increased, the growing number of small stems reduced to the overall average diameter. This pattern is characteristic of early to mid-stage secondary succession, where high recruitment temporarily lowers average tree size. As these trees mature and competition increases, we expect the average DBH to increase again. Next, we're going to be looking at the Shannon diversity. Shannon diversity increased significantly from 2004 to 2025. Regression analysis showed a positive relationship between year and diversity, with the R-squared value of 0.33 and the highly significant p-value of 1.4 times 10 to the negative 8. This indicates that the species diversity increased as the forest recovered. Early after disturbance, communities are often dominated by a small number of opportunistic species. Over time, additional species established, increasing richness and overall diversity. This trend suggests that the forest is transitioning from an early successional stage towards a more structural and compositional complex, mid-successional community. So after looking at those charts, based on succession theory and our observed trends, the forest is currently in a mid-successional stage. As the forest continues towards a climax Acadian forest community, total density is expected to stabilize or decline due to self-thinning, where competition reduces the number of stems. Average DBH will increase as surviving trees go larger and canopy closure intensifies. Shade-tolerant late successional species, such as red spruce and balsam fir, are expected to gradually become more dominant. Overall, the forest will likely develop greater vertical stratification and structural complexity, which are key characteristics of a mature Acadian forest ecosystem. However, because Point Pleasant Park is an urban park, continued management practice and future disturbances may influence this trajectory.
Results and discussion question 2. In 2004, the red maple is the dominant species. Its density is slightly higher than the red spruce during this time period. Although the red maple is more dominant, the relative tree density is fairly low due to the hurricane. The red maple shows an overall positive or increasing trend as the years pass. This may occur due to the early successional nature of the species. In 2004, just following Hurricane Juan, the red maple has less competition and can dominate the park. In 2025, the dominant species is the red spruce. There is an upward trend since 2004. The red spruce increases in density steadily, showing gradual long-term growth. The red spruce is a late successional species, allowing it to develop as resources become available following a natural disaster. As more early successional species develop and competitions for resources increases, the shade-tolerant red spruce gain advantage in growth over the early successional species, such as the red maple. The R-squared value for the total density indicates a moderate relationship between tree density and year, indicating that there is a correlation between the increase of years and the overall tree density. Dominant species moving towards its climax community. As the forest moves towards its climax community, we can predict the red spruce to continue to increase in density or stability at high densities. Red maple may stabilize or decline as competition for resources increase, and the total density will stabilize at its carrying capacity. Why? Early successional species dominate first due to limited competition for resources. Late successional species are slower growing but outcompete the early developing species due to their ability to grow in highly competitive environments.
As we can see, both the Shannon diversity and species richness are increasing. The species richness will continue to increase before leveling off and later declining. This is because new species, typical of mature forests, will continue to be introduced to the area of study. Then, sun-loving early successional species will be outcompeted in an increasingly shaded environment. Then, the forest will reach an equilibrium. Meanwhile, the Shannon diversity index will continue to increase before leveling off. This is because new species typical of mature forests will become dominant, and once they have all been introduced and the forest reaches an equilibrium, the Shannon diversity index will too level off. The Point Pleasant Park forest is a mid-successional forest. We see an increasing trend in the population of both red maples and red spruce. This shows that the forest is, slowly, developing into a climax, late succession, Acadian forest. Red spruce is commonly found in climax Acadian forests. Red maple, on the other hand, is only found in deciduous swamps in the climax forest, but is an opportunistic tree that is very common in early and mid-successional Acadian forests. The fact that both of these trees are still increasing in number indicates that there is still bare ground and a fair amount of light for the red maples, while there is an increasing amount of shade for the red spruce. Eventually, the supply of bare ground will be exhausted, and the red maples will be shaded out and forced to return to the deciduous swamps, while the red spruce will continue to grow in number under shaded conditions, being joined by eastern hemlock, American beech, and yellow birch. The increasing trend we see in species richness likely indicates that these species, common in late successional forests, are starting to appear in the location under study. Because of the still increasing population of red maple, which, on drier soils, is an early successional species, while red spruce, which is a tree typical of late successional forests, is present, we must conclude that the Point Pleasant Park forest is still a mid-successional forest. Factors worth considering in the context of the conclusions on the previous slide include that the Point Pleasant Park is an urban park. This will, in all likelihood, lead to it acting a bit like an ecological island, where species are unable to move between the wilderness that makes up much of the province and Point Pleasant Park. An example might be something like black ash, which is a rare, critically endangered tree found in Nova Scotia. It is another tree found almost exclusively in deciduous swamps. Due to its rarity, it seems unlikely that this species is found in Point Pleasant Park, and, if it is unlikely that it would have sufficient numbers to form a stable population. Um, it is also unlikely to spread to Point Pleasant due to the isolation of Point Pleasant amongst the surrounding urban setting. The lack of this tree will affect species richness in the park. It will also affect the mi'kmaq, for whom black ash is an important species due to the annual growth rings splitting easily, making it the traditional choice for interior ribbing of birch bark canoes and for basket weaving. The relative ecological isolation of the park might also make it easier for invasive species to dominate it. Already, at the Tower Road entrance to the park, Nora maples, which are an invasive species in Nova Scotia, have outcompeted most native plants. The smaller population numbers of native tree species in the park, and thus the likelihood for genetic drift and alleles to become fixed in the population more easily, and thus might make it harder for native species to push back against the invasive species such as Nora maple, which oozes out toxins from its roots, allowing it to outcompete native trees. A mutation that could have allowed native plants to better survive these toxins is more likely to have been lost due to the small population size of species in the park. According to the CBC article cited in the final slide, the Mi'kmaq practiced prescribed burns, which created a more open forest, which allowed for larger populations of game species. Although this would change the successional makeup of the park, as it would destroy such species as balsam fir and American beech, and would favor such species as jack pine, red pine, and white pine, and paper birch, it wouldn't lead to the forest reaching a late successional stage faster, it would just reach there through a different progression of tree associations.
Question 1. Impact of ecological isolation on succession in Point Pleasant Park. Point Pleasant Park acts as an ecological island because it is surrounded by urban development. This means that the seeds from some native trees and plants, especially late successional species, may have trouble reaching the park, which can slow their establishment. As a result, overall species diversity may be lower than continuous forests. The isolation also makes it easier for invasive species, like Norway maple, to compete with native trees. Because of this, succession in the park may follow a slightly different pathway than a typical Acadian forest. It may take longer for the shade-tolerant, late successional species like red spruce to become dominant, and the forest may not fully reach the mature climax community seen in larger connected forests.
These graphs show that the forest trees are young and dense. This indicates that there is a high recruitment rate. The high density hints at a future high competition, as all these trees battle for light. As the trees age, and fewer young trees are able to survive, as less light hits the forest floor, the average dBH will increase. Density will decrease as the trees that lose the battle to access light die, only leaving the winners. The lack of light hitting the forest floor will prevent younger trees from being able to reestablish density.
Question 3. How could the park's recovery have been different if certain plants or animal species had been more or less abundant? Secondary succession occurs when species of plants and animals return to an environment where soil is still present after a natural disaster, such as Hurricane Juan. The park's recovery may have recovered differently depending on which plants and animals are present during its recovery. Pioneer plants are species that are first to grow following a natural disaster. They aid in recovery by stabilizing the soil from erosion, adding nutrients at the end of their life cycle, and providing shade and moisture to the soil that allows other larger plants to grow. These species include grasses, mosses, and small flowers and weeds, and are typically smaller scale plants. If pioneer plants are not present, soil may erode from wind and rain, seedlings of larger plants may struggle to grow, and the overall recovery of the forest will struggle. Animals also play a huge role in the recovery of natural parks. A positive animal presence can allow the dispersal of seeds, allowing plants to spread and grow. Pollinators allow plants to reproduce, and decomposers break down dead materials and recycle nutrients. Although these positives aid in the recovery of an ecosystem, an excess of herbivores may overeat young plants, or invasive species may outcompete native species for food and other resources.
And these are our sources. Thank you for listening.